This mini lesson is on graphing. This is a skill you will need to employ every single lab this year, so it's important that you make sure you understand all parts of this lesson. Your goal for this lesson is to learn to identify the different graph types and to write an equation to relate the variables together. You'll also be reminded of the parts of a good graph. So the parts of a good graph, or the components that you want to have in all of your graphs, are labeled axes, volume in liters, pressure in pascals. The labels must include the variable and the unit. Your axes must also have a valid scale. So in this part, you can see we're going up by 0.01 for each of the lines. You can see going up vertically, they're each worth 100 points. Okay, so 100 pascals, 200, 300, 400, 500. Your graph should include a descriptive title. Your graph should have your points clearly marked. Your graph should have the best fit line or curve for that data type. And finally, you should have an equation for your graph that relates your variables together. The whole goal of doing an experiment is to see how one variable affects another, and then to use that to get an equation that we can use to then predict things that we didn't do in the experiment. Okay, the first graph type that you should already be familiar with is a linear graph. A linear graph has an equation of y equals mx plus b. When you're using LoggerPro and you want to fit a linear graph, you can either pick proportional or linear. The difference is linear will include graphs that have a y-intercept other than 0. So in this case, the y-intercept is 600. You would have to pick linear for this graph type. If your graph goes through 0, 0, then you could pick proportional. The second graph type is an inverse graph. This is a graph where the y value decreases as the x value increases. The equation for an inverse graph is the y variable is equal to some graph constant divided by the x variable. In LoggerPro, you pick inverse by just clicking on the curve fit that says inverse. The next graph is a squared graph. This is a graph where y increases as x increases, but it does not increase at a constant rate, but the increase becomes more and more steep as you move to the right on your graph. In this type of graph, if you double your x value, your y value will go up by 4 times. That's why it's called a squared graph. The equation, your y variable equals a graph constant times the x variable squared. You curve fit this in LoggerPro by picking variable power and then setting your power to 2, which is a squared graph. Similar to this is a square root graph, but now the x value grows more rapidly than the y value. So the y values grow rapidly at the beginning, less rapidly as time goes on. The equation is going to be y equals your graph constant times the square root of your x variable. You can have the x under a square root, or you can just raise it to the 0.5 power. When you curve fit this graph, you're going to pick variable power, but this time you pick a power of 0.5. The final graph type will be a no relationship graph. There are many times where one variable has no effect on another variable. This is known as no relationship. Your points will show a scatter about some average value. You do not curve fit this using the curve fit, but instead you go to the Analyze menu and you pick Statistics. Okay, so here are some graphs. I plotted out the salary that a person earned versus the time that they worked in hours. You can see it is a proportional graph. I chose linear just to show you that the y-intercept would be 0. The slope of the graph is 8.5, and that would be $8.5 per hour. If we were writing an equation for this graph, instead of saying y equals mx plus b, we would say salary equals 8.5 multiplied by hours worked. Here's another example. This one is the time to get to Cape May based on your average driving speed. You can see it's an inverse graph, which means the faster you drive, the less time it takes to get to Cape May. The equation would be time of the trip for the y, 6,004 for the a value, and speed in kilometers per hour for x. Again, this is an inverse graph, and you get that by choosing inverse in LoggerPro. Here's one where we're plotting number of bricks needed to build a rectangular patio with a certain proportion versus the length of the patio. And you could see that this is an increasing relationship, but it's not linear. When you double the size of the patio in terms of its length, you'll need 4 times the number of bricks. The expression to predict the number of bricks would be bricks equals 40 times length squared. Okay, so what you're going to do when you get a data set is you will get 2 variables. You first make sure you put on the x-axis the variable that you were in control of. So if you look, this says the volume of a balloon as the pressure is varied. So the pressure was the thing that you varied. That goes on the x. That's called the independent variable. The volume changed as a result of your pressure changes. That goes on the y-axis. So you would, in LoggerPro, type in your titles, your units, and your numbers for each column. You would then see what kind of relationship exists. Follow the patterns that we saw here, and based on whether or not it's linear, inverse, squared, or square root, you will pick the appropriate function, and then you will write down your equation. You will not be using this data for the graph that you send me, but instead you'll be generating some graphs off of a link from the website. I hope this helps to answer any questions you might have about the different graph types and what they mean.